Hi, everyone. Thanks so much for being here. We're going to get started. Appreciate your patience. We're really excited about this event today. A couple housekeeping things before we move on, just so everyone knows. We do have everyone on mute. We have quite a few attendees today, so we wanted to eliminate any background noise. If you have questions, comments, anything that you would like to share, please feel free to use the chat feature. I'll be monitoring that throughout the event. So without further ado, I would like to introduce Senator Betsy Johnson. She's going to welcome you all to the event today. She has been a huge support of OMIC R&D and OMEP over the years, and specifically been a huge supporter of the Factory of Tomorrow. So with that, I will let her welcome you all today.
Oregon is our most prosperous when we make and export products. Manufacturing is absolutely critical. I would go I was very supportive of Oregon's manufacturing sector, and it's based on that experience that I enthusiastically embraced the notion of OMIC R&D. OMIC R&D is based on the University of Sheffield's AMRC, the Advanced Manufacturing Research Center. We have done, I think, a brilliant job of putting in place the foundation that OMIC R&D needs to succeed. Today, we announce a new partnership with the Oregon Manufacturing Extension Partnership. We are opening the Factory of Tomorrow. This continues to blend the goal of OMIC to bring together philanthropy, government, private business, and academia to solve manufacturing's most fundamental and basic problems. And here at the Factory of Tomorrow, we will use both professional staff and students to help small and medium-sized companies de-risk and debug ventures that they take into technology that makes their manufacturing more efficacious. So the Factory of Tomorrow is going to be foundational in helping these small and medium-sized Oregon companies realize advances in their manufacturing processes without having to make a front-end huge financial investment. This is just one more step in helping Oregon's manufacturing sector bring Oregon the prosperity that we have earned, that we deserve, and that we desperately need in a post-COVID Oregon.
Great, thank you, Senator Johnson. Next, I would like to introduce Craig Campbell, who is the Executive Director of OMIC R&D, as well as Aaron Fox of OMIC.
Hello, everyone. This is Aaron Fox. I'm President of Oregon Manufacturing Extension Partnership, or OMEP for short, as we like to refer to ourselves. I'd like to thank all of you for attending today's event, as we're very excited to introduce the Factory of Tomorrow. OMEP's mission is to work side by side with Oregon manufacturers to help build successful businesses. The adoption of advanced technology will play a critical role in addressing the challenges companies face with ever-increasing competition and the need to continually improve performance. Our goal is to create a tangible, hands-on experience specifically tailored to how these technologies could be leveraged by Oregon's small and medium manufacturers. The Factory of Tomorrow is a space where companies can see and experiment with many different technology applications that translate to real-world manufacturing scenarios. Our hope is that these experiences will demonstrate that Industry 4.0 technologies are not out of reach and can be integrated into any site manufacturing facility. We wanted to provide a solution that de-risks the investment and inspires applications not previously anticipated by visitors to the lab, so that Oregon manufacturers of all sizes continue to be leaders in their industry. Craig?
Thanks very much, and also welcome to the OMEP OMIC Factory of Tomorrow. OMIC R&D is a collaboration of a number of different industry partners from around the world, around the United States, and right here in the Pacific Northwest, along with 3 universities, Oregon State University, Portland State University, and our host, Oregon Tech, along with government and philanthropy. And our primary job is to find solutions to industry's production challenges and find an applied solution that they can put right into the manufacturing line. We also have, as part of our mission, to inspire the next generation of people going into the manufacturing space. But one of our members, OMEP, who we're very grateful for their participation, they're willing to work with us because they're a critical link to small and medium-sized manufacturers through the state, and who comprise a vast majority of the manufacturing capabilities here in the state of Oregon. And so it was sort of serendipity when we came together to have an opportunity to create the Factory of Tomorrow. That Factory of Tomorrow is really designed to allow us to introduce small and medium-sized manufacturers to new and emerging technologies, de-risk the opportunity for them to take those new technologies and implement them into their manufacturing process and allow them to become more efficient, more resilient, and strengthen the supply chain that they're such a critical part of. And I wanted to make a special note to thank the OMEP team. Aaron, who you just heard from, has provided tremendous leadership and participation with us here at OMIC, as has Linda, who's been on our board. And there's a variety of other people who, quite frankly, we couldn't have done this without their involvement. And amongst those is our own Grant Kirby, but also Isaac Forehand and Jason Stratton, Jasmine Agnor, who did a phenomenal job with the design work, Tony Erickson, and Amanda Nordeen, who's joined us very early on in creating this process and making it a possibility. So our hope is that you'll be able to come and take advantage of seeing what we have out here, also knowing that as we continue to do our research and development here at OMIC, we'll be able to contribute that new technology directly into the Factory of Tomorrow so that our small and medium-sized manufacturers can learn about it as soon as we come up with it. So welcome to the OMIC Factory of Tomorrow, and with that, I'll turn it back over to Jasmine.
Thanks, Greg. Thanks, Aaron. We have one more quick message from Donald Hendrickson, who is the chair of the board at OMIC R&D, and he was not able to be here today, but he wanted to just share a
I encourage
message.
everyone to join the virtual launch of the Factory of Tomorrow. This hands-on lab, located at the OMIC facility in Scappoose, is jointly sponsored by the Oregon Manufacturing Extension Partnership, OMEP, and OMIC. The Factory of Tomorrow applies a learn-by-doing approach by providing a series of interactive experiences, including virtual reality, robotics, 3D printing, and more. I look forward to seeing you at their event on September 9th. Thank you.
Thanks. So next, we are going to hear from Tony Erickson. He is the CEO of a local manufacturing company, Oregon Aero. And he is going to talk about kind of how he got connected into the lab and how he's utilizing the Factory of Tomorrow for textile manufacturing training.
So I'm the Chief Operating Officer for a local aerospace company, and we rely heavily on textile manufacturing, textile talent, that is sewing, cutting, patterning, designing. And our workforce is aging into retirement age, and we're one of several companies in this local area that have the same need for the same talent. And in talking with those other companies, we found that they are facing the same challenge. The workforce is aging up into retirement, and there's not a pipeline of talent behind them to fill those positions. Companies across the country are trying to reshore again, and a lot of those rely on that talent, both in aerospace and clothing and anything really. And the same challenge we see coast to coast. We decided as a group of companies that we needed to create a way to develop this talent in the community. We started a textile training program working with workforce development dollars and working with Portland Community College. we put together a curriculum that we use locally here to train the workforce. When I first got involved with this lab, it was through an education channel. We were working on alternative student training virtually so we could bring it in the classroom. We were also exploring the ability to use this training pre-release from prison and get some skills training, workforce training inside the prison system. When Granite first approached me about using this technology to develop our sewers, I really didn't believe it would be possible. I didn't understand the scope of the technology, and I thought it was just too manual and too hands-on for this technology to work. After visits to the lab and discussions with Grant, I started seeing the light that it is quite possible that this could help us out. They have been working on training, virtual training for running and operating a sewing machine, and it's coming along quite nicely, and I'm convinced this is going to be a great asset to our training program.
Thank you, Tony, that is great. So without further ado, we're going to jump into a walkthrough, a little tour of the facility. You'll see some of the different features that the lab has to offer in terms of technologies, and the tour is being led by Jason Stratton, and he is leading Tony, who you just met on the tour. And I do want to add, we did make sure we were practicing proper social distancing and mask wearing as we did this. So here we go.
The Factory of Tomorrow allows you to try out augmented and assisted reality to see how work instructions can be presented to users in a consistent, engaging, and rich new way.
Tony is going to be picking up the Microsoft HoloLens and beginning his work activity. First thing he's going to do today is he's going to log into the application that he will use to view his work instructions. Microsoft HoloLens is actually an augmented reality headset. The headset is designed to overlay virtual images in your real space. So as you'll notice, Tony is interacting with what appears to be objects in midair. But to him, they are objects on his virtual space. So Tony is triggering the RFID sensor that is embedded into the workstation. This sensor is recording the start time for the RFID tag that is attached to the fixture that is holding the collar.
Feel what it's like to work side by side with a robotic arm as it picks and places parts for use during the assembly process.
Tony's now also put in the new fixture that is being monitored by the Cobot. The Cobot has now realized that the fixture is empty and needs a new collar for the work activity to continue. As Tony is following through the work instructions that are being displayed to him on the headset, the Cobot is independently moving and going to grab a new collar for the fixture.
Working next to robotic arm was interesting because it knows what it's doing and you don't exactly know what it's doing at first. With the Cobot, it's a very gentle machine. It won't hurt you. You can stop it. If it runs into you, it's not pushing into you. So it's a very safe machine. And my first 10 minutes, I just was watching the machine because it was fascinating before I got back to actually doing hands-on work and trusting what the robot was going to do. So the place that we can see using a robot, there's tasks that require repetition. They're not difficult to learn, but they can be very boring to do. A robot is ideal for that sort of a task. There's also tasks around sharp objects, cutting tools and whatnot that are potentially dangerous. So you could insert a robot into one of those scenarios and it won't make a mistake. It's not gonna sneeze. It's not gonna cut its finger off.
As Tony finishes the assembly, he is scanning his assembly out of the workstation to record his cycle time on the digital display that is displayed over the workstation.
In our production facility, we work a lot with drawings, we work a lot with instructions, and with patterns. To be able to be at your workstation, whatever your task is doing, patterning, cutting, sewing, to be able to virtually see the list of steps, the quality control checks that you need to make, and some data that you don't have to stand up, go to another area, open up a drawer, get a drawing, look at it, reference it. You would have it virtually in front of you right there. Everybody could be on whatever page they need to be on for whatever step they need to be on.
Lab visitors can also clock cycle times per assembly using RFID tags, record quality data, and view a real-time machine sensor monitoring demo to better understand IoT device applications.
Again, scanning into the station to make sure that the cycle time is recorded. He is now picking up the RealWear HMT. This is an assisted reality headset. The difference between augmented reality and assisted reality is really the difference between holding a phone in front of your eyes or having actual displays being overlaid in your reality. As Tony approaches Station 3, the quality steps are already displayed for him via the Tulip app software in front of him. So as Tony progresses through the station, he's just going to be following the steps indicated on the screen.
And you're not hurting yourself, you're not hurting the equipment. It'll tell you in real time, oops, you did something wrong, go back and retry that step. So you can train repeatedly at virtually no cost. Okay, so I have verified that all 4 components are assembled correctly. I got a picture to work with here. And it would make training a lot faster because they would be able to just have that instructor, in essence, with them through the whole day. And if they have any questions, they can call it up. If they want to reference anything, they can see it, they can read it, they can literally touch that in a 3D space, augmented reality space.
The green button just logged a first pass yield of the pass in the quality database and has returned Tony to the work instruction where he's now ready to start the next cycle in the process.
The data collection was automated. It would save a lot of time in our production and our quality control and our management of production.
The Factory of Tomorrow allows you to experience how virtual reality can be used to train skills, such as taking measurements with calipers, sewing on an industrial sewing machine, or even how to set up a CNC machine.
This experience is designed to give users their first look at how to use a caliper in a manufacturing environment or any other environment to measure objects.
So an advantage that VR training has over a traditional one-on-one trainer is that it frees up the instructor's time to work maybe hands-on with the students at certain levels.
This training is unique because it's in a virtual environment. Virtual training can take place anywhere that the VR headset can be located, which would basically be in any indoor environment with a wireless connection.
But as a student, you're able to go through the steps of the process with a guide, with instructions, with step-by-step, with demos to guide you, and you can make mistakes.
These technologies can apply to any manufacturing sector that requires any type of tracking or tracing from a standpoint of needing to track cycle time. Anybody that needs to be able to track first pass quality data very quickly. Anybody who is having a high volume of turnover and needs some consistent, repeatable training. Any one of the headsets within this process can work and provide that repeatable training without the need for pulling people off of the production line to assist with training of a new operator. What I wanted to show you here today is the OMEP Cloud. What we have done is we have gone out and we have partnered with a software developer, and we've actually built a platform that takes all of the functionality of all those different pieces of software that are valuable to our small and medium-sized clients and built a platform to where all of those modules are now included in a single space. So you have got the ability to have continuous improvement tracking, document control, total productive maintenance, quality management system, learning management system to control the training and training records, all within one single platform. And not only that, but we have negotiated with our partners to make this a low-cost option for clients.
So we can buy into this and store all of our data there?
Absolutely.
There's a lot of pieces and parts that go into everything we make, and they have several stations they have to stop at for steps, whether they're manufacturing steps or inspection steps or any other sort of measurement steps. And we track those manually, and it involves lots of walking around and hands-on and saying, okay, how many of these things do we have here? How many do we have here? Who's going to be doing what next step and where are they located? To have those automated and tracked so we can have the data presented in real time of seeing what's done where and where maybe there's a holdup. Maybe, you know, something broke, something's not running right, somebody's gone. And it's critical to have that in a box ready to ship at a certain time on that day. You'll see that early enough that you can intervene and you can prevent that failure.
These technologies are meant to be a jumping off point. Bring your own ideas and applications to the space. Book a private tour for the physical space to discover your unique opportunities for the real-world application of advanced manufacturing technologies.
Awesome. Well, that gave you a little taste, kind of a little preview of some of the technologies in the space. And we do invite, as Jason mentioned at the end of this video, we do invite you all to book a tour if you're, you know, local in the area. But the good news is, even if you are not, you know, local, or if you're just not able to get up to the facility, one of our fantastic partners in this process, Isaac Forehand of Ideality, has created a 3D version of the Factory of Tomorrow so that anyone from anywhere can look into and experiment with the technologies, and then also learn more about how they can be applied in your facility.
Thank you for joining us at the Factory of Tomorrow. If you are unable to make it down right now, have a tour of the real lab, feel free to take a walk through our web-based virtual lab and learn more about some of the advanced technologies that are available. While in the virtual lab, use the mouse to look around and use your arrow keys or WASD keys to navigate the scene. Feel free to learn more about any of the technology available.
And I will be sharing a link as a follow-up so that any of you in attendance can utilize that virtual experience of the space. So I know that was a lot. We just went through a bunch of different technologies, applications, possibilities. We're gonna jump into a Q&A now. So Aaron is available, and Jason is also available to answer questions, Craig. So feel free to utilize the chat for the Q&A functionality and ask questions about whatever you might be curious about.
Hey, Jasmine, I'd like to kind of kick this off with a little thank you that I wanted to make. Craig, sitting over there in the real Factory of Tomorrow, and I'm sitting here in my virtual Factory of Tomorrow. We're very excited about this. It's taken longer than we had anticipated. Obviously, COVID had impacted this launch, but the fact that we were able to pull it off and do it virtually, it's just a testament to the team. So I wanted to make sure that I thank the Factory of Tomorrow team for all their efforts in making this a real destination for Oregon companies to advance their factories and strengthen their workforce capabilities. We'll continue to expand and integrate new technology applications into the lab over time. And also I wanted to thank Craig. He's been a fantastic partner in sharing OMEP's vision of what this should be. And he and I both joke about Optimus Prime someday. So hopefully in the not too distant future, you're gonna see a version of Factory of Tomorrow visiting your communities across the state.
Thanks, Aaron.
I was going to reciprocate by saying what a great opportunity it's been for us to work with the OMEP team and the team that's been here working hard and making this is just a gorgeous space. But I see we've got questions coming in, so I didn't want to take up good Q&A time, but did want to thank those folks for just working with this team has been phenomenal. They're just very, very talented, and you can tell that we're going to continue to grow and change in the coming months and years as new technologies come about. But I have every confidence that the group that's been working on this is going to be able to adapt to everything that comes its way and make sure that it's approachable and and adaptable for those who come in to learn about it and make it part of their own manufacturing process. So, all right, so we've got some questions coming in.
Yes, I'll go ahead and read them in the order that I'm receiving them. So Jeff Mason asked, we just purchased a HoloLens headset and was wondering if you know of a good resource to speed our deployment.
OMEP.
Yeah, absolutely, Jeff. We can have you reach out, and we can certainly put you in contact with some of our partners. There are some good applications for use on the HoloLens that work very well for simply recording either live activities that can be embedded into work instructions, and it also has a very solid web interface that you can use to actually build the work instructions and experiences that you want to have out.
And I would also encourage, if you'd like, to leverage the Factory of Tomorrow lab and come on out, schedule a visit, and see what we're doing out there with augmented reality and some of our future plans as it relates to knowledge capture.
Great, thank you. Ted asks, what's the process for other companies to get involved? Where do you need help?
Well, let me jump in. This is Grant. Let me just jump in real quick and say that what we really want to be able to do is to find those tools that work well for your organization. So if you have a particular tool that we don't have, we have several now, but if you have something that you would like us to try out and run some programs against your needs, feel free to invest in those tools for us to use there. We'd be glad to try them out, see how they work, see how the software works with them, and really try to figure out how to apply those tools to your particular situation.
Yeah, I mean, specifically regarding, how companies get involved, Ted, pretty simple. Just go ahead and contact us and set up a time. We'll schedule a time when you can come to the lab and visit and, maybe talk through some of your more specific applications.
And we're very interested in understanding the specific needs for companies as it relates to these technologies. And as Craig pointed out, our intention is to continue to expand capabilities as well as applications. So any new application we can toy with and help you guys throughout the process, it also helps the manufacturing community across the state in allowing us to add more experiences for others to participate in.
Yes, thank you. So Joe asks, can you clarify the difference between a cobot and a robot? Also, how open is the workforce to integrating robotics to the manufacturing operation? Great question.
Sure. So a cobot is really designed to make sure that it is a safe activity. It has sensors and actual safety protocols built into it, whereas a robot is going to follow a designated program no matter what, whether it runs into a person or something else. So the cobot is really designed to work next to the workforce. As far as the workforce integration goes, we have found that there's a lot of excitement around activities that employees just absolutely detest doing, things that are simple and yet painful and repetitive. They are all too happy to have a cobot come in to free them up to do more of the complex manufacturing tasks.
Great, thank you, Jason. Next question, how much time and effort does it take to create a virtual training module? And this links to another question from Debbie, which is around, also what is the time and personnel, kind of cost to set up a training program?
Yeah, that's a great question. I'll let Jason start off on that one.
Yeah, so it really is going to depend on the application and the complexity of what you're looking to train. Obviously, the more complex and more challenging the operation it is that you're trying to train, the longer it's going to take to actually create the virtual training module. And then of course, then the cost goes up. However, if it becomes a situation that it is something that you are constantly training on, the return on that investment becomes very clear very quickly, because you create the system once or the training once, and you can then deploy it hundreds and hundreds of times if necessary, and you can move it around the world if necessary.
Yeah, there's significant interest I've heard from folks as it relates to trade shows and booths, and when companies are moving large pieces of equipment or displays to be able to do that virtually, you know, just it gives them all kinds of options. The other thing I would add to that is there is the augmented reality portion of this as well that, you know, kind of can support what companies are doing on the virtual side. So I'd certainly recommend learning more about both applications.
I throw one more thing in, that ultimately this could be used as a tool to provide early opportunities in high schools where the opportunity to have hands-on work with a machine is not as likely, because it may be a low-income school or a rural school where they don't have the opportunity to afford many machines, let alone one. And the AR/VR solution can actually go a long way in doing the initial training before they have to be on a live machine, and do so very inexpensively, because you're not using power, you're not using material, you don't have the cost of the machine itself. And of course, those who are learning through virtual reality can break the machine while they're developing their muscle memory and learn from their mistakes before they ever get on a machine where a mistake like that would be more costly.
Thank you, that's great. In connection with that question, Debbie also asked, you know, is OMIC or OMEP making recommendations on the vendors that provide the hardware? What is that? How does that work?
OMEP, I'll speak for OMEP. We do not make recommendations on vendors, but we like to understand the different companies that are out there playing in each space, and know them well enough that we can provide information for folks to be able to make educated decisions.
I'd say similar with OMEP. Of course, we have a number of members who are manufacturing tool. Well, they make machine tools, they make cutting tools, and people are certainly welcome to come and try them out here with those members. But beyond that, we can do handshakes, but we don't make formal recommendations as to what type of equipment to use. It's really what's best for you and your company and your situation.
Thank you, that's great. Another question here. Looks like, are you using Tactile's Manifest software for your RealWear HMT1 headset? If not, what software applications do you leverage for this? That's from Rob.
Yeah, so Rob, we've actually tried to put a variety of different software solutions to match up with our hardware. So we are not using Manifest on the RealWear HMT1. We are using a software called Augmenteer that allows for the voice control of the application to allow you to shift through the different work instruction steps and be able to set focus on a specific image or drawing as it pulls up. So yeah, we like I said, we've tried to keep and present a variety of options within the lab so everybody can see the differences between the different software.
Thank you. Another one from David Flood. Is this AR tech with SolidWorks assemblies animations, or do we need a proprietary software?
So actually a really good question. So some of the animations within the software that is being presented have been created in SolidWorks and a variety of other different rendering engines. Again, we've tried not to be specific when it comes to those things, but right now we found the easiest solutions within the software do handle just about any type of models that are generated on most of the platforms.
Thank you. Randy says, cool stuff. Is a practical application to map out a real space, like a floor plan for a training about where things are, like exits or fire extinguishers, or where tools and machines are located? Or are there better practical applications?
Absolutely, Randy. In fact, it's been one of our bigger success stories when it comes to the virtual reality space, is to work with clients to actually go into their factories and map out their space, so that when they're thinking about doing floor layouts or redesigns, we actually are able to allow operators to jump into the virtual space and see what the new layout looks like and feels like before actually making a move to try to get rid of some of those objections or concerns on the front end of a potentially expensive move.
Yeah, I actually had the great opportunity of sitting in a hot tub in one of our clients' virtual sites. It was pretty cool.
I might bring up the fact that we had some interns this summer who did just exactly that. They created a VR walkthrough of the OMIC facility. And you know, they went from kind of zero to that in 8 weeks, which was pretty astounding. Thanks to Isaac forehand for his help. But that's a very cool way of being able to show your facility. If you're thinking about safety issues, or you know, where people find resources within a facility, it's a very simple way for that to work.
And another application where augmented reality tools can provide another experience that is beneficial.
Thank you. Ryan asks, can you expand on what appears to be an MES package? It appears you have combined CMMS functions within a common platform. What differentiates this from the commercial offerings out there?
Ryan, that's a really good question. You know, when we started building the OMEP cloud, we started by looking at all of the different commercial offerings that were out there and all the different functions. And the answer to your question is there's not a huge amount of differentiation, other than the fact that it's all integrated. It's one single platform. And of course, then the pricing standpoint. Usually you have to spend a monthly fee on each individual module, whereas within the OMEP cloud, we are just having a low monthly installment for all of the modules and all the features that come packed into that system.
Thank you. All right, a couple more questions here. So Ashley says, we in Lane County are working on designing and launching an industry recognized textile manufacturing curriculum. How can we partner and possibly utilize what has already been created?
Well, this is Grant. Let me just jump in to say that we worked with Tony Erickson to do this initial work with a view of being able to roll that out to the textile industry, because the workforce development in textile has been a problem for quite some time. So this was an answer, thanks to Tony and his crew, to help us take a look at that. We'd love to be able to work with you to support what you're doing, if that makes sense, if we can afford to do that. And our purpose here was to supply help to the industry, not to compete with it or to do any other thing that would detract from what you're trying to do.
But yes, I mean, again, the best way probably is just, you know, get in touch with me, Jasmine here at OMEP, and then I'll connect you with Brant, and you guys can continue the discussion, but that's really exciting. Another question from Debbie, just wanting to clarify this, is there a cost to use the facility?
So currently, right now, the facility does not cost anybody anything. Over time, we want this facility to pay its own way. I mean, OMIC and OMEP have graciously funded all of the work so far, but our hope is that this tool or this research lab will pay its own way. So if people want to use the lab to do things for themselves, we just like for them to kind of pay their own way, but there's really no cost associated with coming up and using the lab unless there is.
From OMEP's perspective, our goal was to make sure that we were introducing OMIC R&D's capabilities to the small and medium manufacturers and creating a venue that provided immediate value for them. And we felt like this was a great solution for folks to learn and understand different technologies and how they could apply in their mixed model environment or low volume environment, but also give them an opportunity to learn more about OMIC R&D and what they bring to the table. Our desire would be to see our manufacturing companies leveraging all the resources that are out there for them, and ideally along the path, making sure that as they're building these more competitive businesses, that part of that long-term plan is technology.
Thank you. Another question from Debbie, interesting one. Is there the capability to use some of this technology to determine that whether a person is a good fit for a position? Sort of use it as some kind of a simulator to determine if the person meets, is able to complete the tasks that are required.
This is one of the reasons that we started the textile or the sewing machine piece. This is an interesting job, and not everybody's well suited for that kind of work. And so quite a bit of the cost to train people is to look through several applicants to find out which ones could actually do this kind of work or would like to do it. So the answer is absolutely yes. Part of our workforce development effort is to do exactly that, is to introduce people to various aspects of manufacturing and find out where their propensities are, where things work well for them. Some people will do well. Some people just don't have the motor skills, for example, to do fine detail. This would be a way for them to find that out early and to be able to either self-screen or for employers to be able to find out which people are the best fit for a position.
Great. And with that virtual training, Debbie's asking, can a trainer see and observe without being in the same room or maybe even in the same location as the person they're training?
Currently, the technology allows for that to happen, certainly. We have to program that in, but you can look over somebody's shoulder and see what they're doing if you desire to do so.
Great. Rob asks, the technology has tremendous power to boost customer service experiences for rapid remote troubleshooting. Have you performed any experiments or proof of concepts in this space?
So yeah, Rob, unfortunately, we have not actually done any of the experiments or proof of concepts with it, but you're absolutely right. It does have the capabilities. It is actually very well suited for exactly that. And we would actually love to invite you to come out and be a part of a proof of concept. We would love to participate in that with you.
Oops, I don't see any additional questions here. Another one here. What safety concerns do you have, or maybe how do you manage safety concerns around with these technologies, and how do they affect safety?
Yeah, so one of the biggest concerns with regards to virtual reality, obviously, is the fact that you are not exposed to your external environment. So there are some safety considerations that need to be taken with the amount of space that you're actually exercising the actual experience in. But beyond that, like I said, with the cobot technologies and the other technologies, they are all very safe applications, and we have taken them through to make sure that safety is of the highest concern.
I might add that you can programmatically make the programs as rigorous as you want. So you could allow people to be have their fingers cut off, or you could crash the airplane multiple times, right? So depending on how much you want to invest in the safety aspect of that, you can simulate real life situations that somebody would experience at that time. The difference is that they won't be harmed. They'll just get the reset and try it again.
And that's really the key, is trying to eventually get this to the point where they are sufficiently realistic that you, as you're learning, are experiencing what you would in real life. So when you do make a mistake, it's not just a red note saying you made a mistake. It's a realistic feedback that that informs you and builds into that muscle memory and your natural responses, rather than just kind of a rote educational opportunity.
Yeah, I think obviously there can be safety concerns with any manufacturing floor, but overall the intent for all of these technologies is to create a safer workplace, and that being not just on-the-job injuries, but from an educational perspective, preparing people to be able to function in a work environment in a more safe way by training them in an environment where they don't have any safety concerns. With the cobot, that's the difference between a cobot and a robot, is that it can safely work next to human beings, provided human beings don't put weapons in the cobot's end effector. So the intent is for all these technologies to create a safer environment. I should say one.
Well, I think we're just wrapping up here. I don't see, one more question just popped in. Robert asked, what resources are available to create new programs? Are programmers available that can be employed to create a custom training program? And how are you handling the need for, ongoing updates to those programs to adapt to a dynamic and constantly changing environment?
Yeah, that's a great question. Obviously, we're introducing the Factory of Tomorrow for folks to have an opportunity to come in and experience these technologies and get some ideas around, how they would like to apply them in their own work environments. As part of OMEP's standard service offerings, is we do help companies with workforce solutions, and a big element of that is developing on-the-job training programs. Our significant interest in AR and VR is enhancing those on-the-job training programs, and that's why we've really tried to be at the cutting edge of those technologies, as well as integrating those into some kind of cloud-based solution. Specifically, Jason introduced one that we've been working with a partner on, so that managing that overall learning management system and the overall training programs and the required updates are able to be accomplished as efficiently as possible.
Great, thank you. Greg from Work Systems is asking, has this rollout been presented or connected to the K-12 system within the Portland metro area? How would you support students that have an interest in this but don't have the tech capabilities, i.e. they don't have the tech to make this work?
Well, I can say that this summer we had some students from Scappoose High School as our pilot internship, specifically supporting the lab, and we had some students working on the robotic side of things, and other students working on the VR programming side of things. So we're committed to pushing these technologies down into, as early as we can get there, access to these kind of tools and the support. The problem, of course, is that it takes a fair amount of mentorship on our part to help guide these students. But we did have a kickoff pilot this summer, an internship specifically to address that issue.
I think another thing that this question gets to is the availability of, even if you have a school that is doing this sort of work but doesn't have access to machines, it probably also doesn't have a lot of money available for the AR, VR equipment that would be necessary for a student to learn, much like we experienced when COVID identified a lack of access to Wi-Fi and computers and things like that for students who had to work remotely. So there's not an easy answer to that. That's going to be a process of working with the school districts, finding people who are willing to contribute either resources or these headsets to those who need them for learning. So there's a lot of hand-in-hand collaboration that's going to need to happen before we're going to be able to effectively transition this to the K through 12 system. But it's critically important that we do that. So it's well worth the effort. It's just going to take some.
Yeah, I echo Craig's comments in that, you know, when he and I originally talked about this idea, I jokingly talked about Optimus Prime, but that was really what we both were seeing, in that how do we make sure that rural communities, or any community, but specifically rural communities, could have access to these technologies. And that still is our long-term vision and goal, is to make sure that it's benefiting business, but it's benefiting K through 12, because benefiting K through 12 students in building these capabilities, competencies, and interests in becoming part of the manufacturing community just strengthens the workforce for overall manufacturing, and it's good for all. So you know, our hope is that we can bring this technology to schools to help generate interest.
And along those lines, Greg asked, what are some of the jobs that would be supported with these trainings? Are there, you know, livable wages within this space? And what's some of the, you know, potential growth here?
Manufacturing median pay is higher than other industries. It's certainly living wage jobs, and I would argue very good living wage jobs. And I think, unfortunately, kids just aren't aware of that. The sky's the limit for any student that has interest and is willing to put forth effort. And I've worked with manufacturing companies my entire career, and have seen kids with a high school diploma skyrocket through their career within a manufacturing company and making very good salaries just because they were curious and wanted to solve a problem and were willing to make the effort to learn what they needed to learn to solve that problem.
And beyond that, this is a technology that can also be used to allow those, once they get into a manufacturing position, to continue to advance as technology advances, because machines are constantly becoming more technologically advanced. And we need to find a way to constantly improve the training to allow those employees to grow with the technology, grow their job opportunities as well.
Thank you. And last, I would say, I think Rob sums it up really well. He says, I am excited by what you're building in this space and what this can do for businesses throughout our region to introduce and adopt this technology, so that businesses are not intimidated but encouraged to get started in this area with practical hands-on learning to demonstrate the value. And I couldn't agree more. I'm glad you feel that way, Rob, because we feel that way too. I think we're going to go ahead and wrap up now. So again, if you want to book a tour at the facility, you can go to our website at omep.org/Factory of Tomorrow. There's a form on that page you can fill out. You can also click through to read more about the technologies that are currently in the lab and a couple of our future projects that we have planned. And I'll turn it over to the rest of the panel. If you have any closing remarks, feel free.
I think Rob nailed it pretty well. The whole goal is to make this kind of technology available and approachable. And with the great people at OMEP who can also provide consultation to help make that transition occur, that was really the whole goal of the Factory of Tomorrow. And we're hoping that we will, we're going to make this something that will have an impact on small, medium-sized businesses, not just in this region, but throughout the state.
Yeah, that's fantastic comments, Craig. Let's ask Rob to present next time. He nailed it. I just want to thank everybody for participating and learning more about what we're doing. We are really, really excited about this, excited about the partnership, excited what it means for Oregon businesses, as well as, you know, the opportunities for great long-term careers for our students and K through 12 students here in the state of Oregon.
Thanks so much, everyone, for being here. We'll be following up with links and a copy of the presentation. Have a wonderful rest of your day. Thanks, everybody.
Thanks, everyone.